All right, let's take a look at example 6 now. It says consider the absolute value function f of x is equal to the absolute value of x squared minus x minus 2. All right, you might recognize this as a parabola, x squared minus x minus 2. All right, this is a parabola. It opens up. If we're going to sketch the graph of this parabola, we probably should complete the square and figure out what the vertex is. So let's see, this is x squared minus x plus 1/4, subtract 1/4, subtract 2. This gives us y is equal to x minus 1/2 squared minus 9/4. Right, so we have a vertex of 1/2 and 9/4, and it opens up, and it's normal in width. So let's see, 1/2. Oh, 1/2 and negative 9/4. 1/2 and negative 9/4 is about there. 1 over, 1 up, 1 over, 1 up. Alright, just going to pass through those 2 points. It's going to look something like that. Alright, let me draw that in green now that I've drawn it. Alright. Now, let's see. A, it says determine the y-intercept and the x-intercepts. Alright. The y-intercept, again, means x is equal to 0. So all we need to do is plug in 0 squared minus 0 minus 2. So we get the absolute value of negative 2. And so we get y equals 2 as our y-intercept. Right. The x-intercept is found by setting y equals to 0. And again, we can use our original equation to find our y-intercepts. So 0 is equal to x squared minus x minus 2. This is a quadratic function, so we've got options here. We can solve by completing the square, factoring, or using the quadratic formula. I recognize this as factorable as x minus 2 and x plus 1, right? Because 2 times 1 is 2, and negative 2 plus 1 is negative 1. So we get 2 x-intercepts. One's at x equals 2, and at x equals negative 1. Right there, x equals negative 1 and x equals 2. Alright, now let's sketch the graph. It's good because we've sketched the associated graph. Whenever the graph is above the x-axis, our graph follows perfectly the original graph. When it skips above, though, below, we have to reflect it above. And so the red graph is y equals the absolute value of x squared minus x minus 2. Alright, they would like us to state the domain and range. Alright, the domain is going to be the same as the associated function, and because we're just dealing with a quadratic function, its domain is all real numbers. Alright, the range, in this case, it's y such that y is greater than or equal to 0. This is commonly going to be the range for an absolute value function, but it is not always the range. There will be times, especially when you're sketching the absolute value of a parabola, that this could change. All right, the last step is to express this as a piecewise function. Now, there are two pieces. There are times when we don't have to change the sign, and there are times when we have to change the sign. Now, we don't have to change the sign over here. If you notice, any part of the graph over here has an x value that's bigger than 2. All right. And if you take a look over here, we don't have to change the sign of our y. And so we've got that is x, our x values there are less than -1. In between -1 and +2, we had to reflect the graph. And so we get that we have to switch the sign when x is between -1 and +2. And those should probably be strictly less than signs. All right, so remember, when you want to sketch the graph of an absolute value function, sketch the original function without worrying about absolute value. Anywhere the graph passes below the x-axis needs to be reflected above it. All right, and for practice for the absolute value of functions, your assignment is on pages 375 to 379. Do numbers 1 to 4, numbers 5 to 11, only the odd parts, A, C, E, etc., and 12, 13, and 18. Thanks.